And so we have two different spinners. Is this going to be an independent or a dependent example? Please erase the board for me. When you're looking at your two different spinners at the top, we're going to do number 2 because they're close next to each other. First of all, are these two events independent or dependent of each other? Spinner on the top. What do you think? Independent or dependent? I got two different spinners. What do you think, Tom? Tell me again. Does spinning this spinner change this spinner?
Oh, no.
No. So if nothing changes, is it independent or dependent? It is independent. What is the probability of getting a 1 on this spinner? What's the probability of getting a 1 on this spinner? Natalie? 1 out of 8, because there's 1, 1, and there are 8 spaces. You're correct. What's the probability of getting an A on this spinner? What's the probability of getting an A on this spinner over here? Jenna? Good. 3 out of 6 is what fraction that we know and love, Grace? It's 1/2. So I like to, if I know automatically that I can get a factor out of the top and the bottom, I do it. And then those two fractions, I do what? Multiply. 1 out of 16 is the answer. 1/16. Independent. Not so bad. Want to do another one? What's the probability of getting an odd number on this first spinner? What's the probability of getting an odd number? Mackenzie, how do you know there are how many odds? Out of? Good. So she reduced right away because it's 4 out of 8. The probability of getting an A is, Tristan, 1/2, because we did that one up here. It's 3 out of 6. What do I do with my two fractions? Tom? Multiply. So the probability is 1 out of 4. Good work. Let's switch now to this game. And we're going to do number 8 because you can see it in the middle. And all of these are going to refer to this story part right here. There are 10 yellow, 6 green, 9 orange, and 5 red cards. All face down. Once a card is selected, it is not replaced. We're going to find the probability. If it is not replaced, is this one independent or dependent? And how do you know, Gavin? Awesome. Perfect. He's spot on. When you take one away, it changes what the probability of the second thing is. Well, how many cards are there total? Because we need that for probability for sure. How many cards are there, Natalie? Huh? Anybody know how many total cards there are? 30. There's 30 cards total. So the probability of picking 2 green cards, we're going to do one thing at a time. What's the probability of getting a green card the first time? How many green cards are there? 6. So there are 6 green cards out of how many total? How many cards are there? 30. Yeah. Whew. 1/5. 1/5. I like that. I'm going to make that one 1/5 already. Okay. But now I am hanging on to that green card. How many green cards are in that stack now? Gavin? No, because I'm hanging on to one. So how many are there? So there's 5 left over. And since I'm hanging on to one, how many are left in the stack? There's not 30 anymore. There's how many? 29. So the denominator changes because this is a dependent event. Dependent event means the denominator of the second one changes because you're hanging on to one. You're hanging on to one. Anybody see a common factor? Yes, Marcus? 5 and 5 makes the multiplication easy. It's 1 times 1 is 1. 1 times 29 is 29. That is my answer. If 7th graders are going to make a mistake, it's on this second denominator. Every time. Don't be that 7th grader. On this side. Let's do another one of those because I think the dependent ones are tricky. Probability of a red card and then an orange card. It's not replaced, independent or dependent. If they are not replacing the card, independent or dependent. Marcus? Still dependent. So how many ways can I get a red card? How many ways can I get a red card to start? Natalie? Out of? Good. 5 out of 30. 1/6. We can reduce that. I am loving that do you see why you have to know your multiplication and division tables? Otherwise the math gets really painful. So if you're not there yet, get there. So that's the first card. Well, how many orange cards are left in the stack? How many orange cards are there? Marcus? There's still 9. So this numerator doesn't change because we didn't take an orange card to start. So there were still 9. But how many cards are in the stack if I'm hanging on to a red card right now? How many cards are in the stack now? Because I'm hanging on to one. There's 29. Good work, Destiny. What am I going to do with my two fractions? Multiply. Do you see a common factor? I do.
Yes.
Good. 6 and 9. Both have a factor of 3. I got 3 and 2. 1 times 3 is 3. I'm going to mental math this. 30 times 2 is 60. That would be 1 less times 2, so I'm going to take 2 off. It's 58. Did you see how I mental math that? It's so close. Because we crossed off this 5 and this 5. And took a factor of 5 out of the top and the bottom, so they're both 1. Do we need to do another one of these? Or you think you're good? Do one more? No, one more? Let's just do 12 just because. This one is a tricky one as well. So 12 says this. 2 cards that are neither green nor red. Well, how many red and green cards are there? 5 and 6 is 11. Well, if 11 of them are red and green, how many are not red and green? If 11 of them are, how many are not? M. Perfect. So 19 out of 30 to start are not red or green. But I drew a not red or green out, right? I'm drawing one out and I'm hanging on to it because we're not replacing it. So how many not red or greens are left over if I'm hanging on to one?
19.
But I'm hanging on to one. There's 18. So in this one, the numerator changes because I'm hanging on to one of the ones I want. How many cards are left in if I'm hanging on to this one? Jenna? 29. She's right. So here, the numerator didn't change because we didn't have an orange card to start. Here, we took out one of the ones we want, so there's one less to have. I see a common factor between 30 and 18. What is it? Yes?
2.
You could go bigger than 2. You can go bigger than 3. 6. Pick the biggest, greatest common factor. That'd be 5 and 3. 19 and 29 are both prime numbers. Okay? I'm going to mental math it again. This is really close to 20. So 20 times 3 is 60. Then I'm going to take away the 1 from each of the groups, which is 3, so that's 57. I'm going to mental math this one too. It's really close to 30. So 30 times 5 is 150. Take away this 5 because there's 1 from each group. It's 145. Do you see why you want to get rid of those factors first? This is actually reduced to lowest terms, but those crazy numbers, how would you know if you didn't look for the factors here? Yes, M? Nope, you do not. It's a great skill to have, though. So that's why I'm doing it out loud, so because if I say it, some people then can start to be like, oh, all right. You need to do the odds on this page. You need to do the odds on that page.